Look at the threshold, 20 out of 30 for A. This is October 15, November 15, and paper variant is 53. So please mark the threshold.
Okay.
The halogenoalkanes can react with hydroxide ions to form an alcohol and a halide ion. The rate at which the reaction occurs depends on which of the halogenoalkane is chosen. The reaction is a nucleophile attack by the hydroxide ion, and the rate might depend on the polarity of the carbon halogen bond. And the bond strength of the carbon halogen bond is talking about the AS reaction. For 1 and 2, chlorobutane, bromobutane, and iodobutane should be considered. If the rate of reaction was only controlled by the polarity of the carbon halogen bond, the order reactive would be most reactive to least reactive would be what? Now, CCl bond, CBr bond, and CI bond. So he says if I consider the polarity, only the polarity, obviously when if I say the word polarity, and second he says the variation in the polarity of the carbon halogen bond, chlorine is the most electronegative element. Then comes chlorine, then comes bromine. Electronegativity decreases down the group. Greater the electronegativity, greater the polarity of the bond. So 1A. In our AS chemistry, this topic was there. So halogenoalkane, in a halogenoalkane, the carbon halogen bond is polar like this. Carbon halogen bond is polar. And if the rate of reaction was only controlled by the polarity, so polarity, in terms of polarity, what happens that electronegativity is the maximum for chlorine, then bromine, then iodine.
So the carbon and chloride bonds would be the most reactive.
So should I say the reactivity decreases down the line?
Yes.
Reactivity will decrease and I want to show this thing. This was in our PS. RCX bond is polar and the OH minus is the hydrolysis nucleophile. It is attacking the positive carbon. So chlorobutane is more reactive than bromobutane, which is more reactive than iodobutane. It would be better if you copy this structure also for a memory connection. Yes.
Okay. I've copied.
Explain the variation in the polarity of the carbon halogen bond. This variation is coming from the idea that down the group electronegativity decreases. Polarity depends upon electronegativity difference.
Mm.
So fluorine is the most electronegative, then chlorine, then bromine. So CH bond, in terms of polarity, the polarity of the bond decreases. Why? Because electronegativity decreases. So now look at this solution. You have to copy it, but understanding is required here because of
Yes.
the electronegativity.
Okay. I've copied.
If the rate of reaction was only controlled by the bond strength. Now, this is an interesting concept. As the polarity increases or decreases, the bond length changes, and the change in
Yes.
bond length will also affect the bond strength. A shorter bond is stronger than a longer bond. A shorter bond is stronger than a longer bond. So now think about this option. How should we write this?
We should say that the ionic radius of the halogens increases down the group, so there will be a longer bond with iodine and bromine than, let's say, with chlorine. So the bond strength decreases, I think.
Right. CI, CSL bond length decreases. So the bond strength decreases. So reactivity increases. While the previous thing was predicting that the bond polarity decreases, so reactivity decreases. In the previous case, we should say that reactivity decreases. Why the reactivity decreases in the previous part? Because
the polarity decreases.
yes, and the whole reaction goes on. So here the reactivity increases, bond becomes weak. Weaker bonds can be broken easily. You have to share this.
Okay. I've copied.
In chemistry, this is called subtle effect. Same phenomena, but opposite effect. One feature is increasing the reactivity or trying to increase the reactivity, and the other feature, the other feature is trying to decrease the reactivity.
Yes.
An experiment can be carried out to compare the extent of the reaction between aqueous hydroxide ions and chlorobutane, bromobutane, and iodobutane. Samples of the halogenoalkanes are reacted with sodium hydroxide for 2 minutes at 50 degrees. Sodium hydroxide is a source of hydrolysis here. After this can be considered as alkaline hydrolysis. After the reaction, addition of aqueous silver nitrate. What silver nitrate is doing here, because if reaction gets successful, halide ion will be leaving the system. Silver nitrate is a famous reagent because it can combine with a halide ion, giving a colored PPT. So some hazards associated with the use of halogenoalkane, very hazardous in case of skin and particularly eye contact, very hazardous if inhaled or ingested, flammable. To carry out this experiment, following would be supplied: usual laboratory apparatus, laboratory reagents, samples of each of the three liquid halogen alkanes. Identify the dependent and independent variable. This has to be done always very carefully. But people make a common mistake here. They think that only one option is there. But in case of chemistry, unlike physics, there are more than one option.
Mm.
So he says that basically he want to, if we go back and read the question, to compare the extent of the reaction between aqueous hydroxide ion and chlorobutane, bromobutane, iodobutane. So if you read the question carefully, what you are changing chlorine with bromine with iodine. So this is our independent variable. What it will change? It will change the amount of PPT. Why it will change the amount of PPT? Because when you form, if we recall from our AS, silver nitrate is AgNO3. AgNO3 break into Ag plus and NO3 minus. Silver is a very good friend of halogen. So suppose in solution Cl minus enter, it will form silver chloride and settle. It's a PPT. Now, obviously, when bromine is there, it will form silver bromide. But silver bromide, bromine is a heavier element than chlorine. So silver bromide PPT will be more in amount. Iodine will form silver iodide, but it is then more in amount. So we have two variables. One, we will consider the halogenoalkane. What halogenoalkane we are using? And second is the amount of PPT. So you have to copy this.
Okay. Okay.
The amount of each halogenoalkane liquid to use is most practically measured by its volume. Usually equal volume of the three halogenoalkanes are used. Explain why this is not ideal and what change should be made to obtain a more reliable comparison between the halogenoalkanes. If we keep the same volume, but chlorine, bromine, iodine are not in the same molar mass, then obviously iodine in the same volume will be of different number of moles. So we are actually introducing another variable. So in physics, we say that at a time, only two variables should be involved. So part 2.
What if we measure the amount of sodium hydroxide?
No. Number of mole, na? O-level chemistry.
Oh, okay.
For a fair comparison, you should not equate the volume. So 1 liter chloroalkane is not containing the same number of moles if I have 1 liter of bromoalkane, definitely bromoalkane has a bigger mass.
Yes.
I should not use the same volume. Uh, I should be using the same number of moles.
Okay.
Have you copied it?
Yes.
Answer the following questions about the experiment. Having measured the quantity of halogenoalkanes, what must be ensured about the amount of sodium hydroxide used? So we are measuring the halogenoalkanes. We are taking their number of moles. Now he wants, what does this mean that actually? He means to say what you want to make sure about sodium hydroxide used.
Can we say that we should make sure it's the same amount?
Otherwise, if we use different amount of NaOH, so right, that makes sense. Same concentration of NaOH. How would the reaction tube be heated and the experiment be started? Examiner already have mentioned us that there is a flammability issue. So when there is a flammability issue, we should not heat it directly. We are using a water bath. It's like a thermostat apparatus.
Mm.
When the temperature reach 50 degree, and start the timer quickly. what reagent could be added which would ensure that after 2 minutes the reaction was stopped? There is a famous reagent which is called nitric acid. How nitric acid can assure us that it will stop the reaction?
Maybe the nitrate ion.
The nitric acid is a strong acid. And if you remember, this is a memory case that when silver nitrate test is used, it is always acidified. The H plus ions will also consume the remaining halogens. So it can stop the reaction within 2 minutes. After the reaction has been stopped and aqueous silver nitrate added, the amount of precipitate formed could be determined by measuring its height. Why is it necessary to leave the tube for some time before making this measurement? So why don't we immediately measure the height? Why we should wait? This looks to be a bit common sense question because chemical substances do not complete suddenly, quickly. We should give some time so that precipitation completes.
Yes.
Although the amount of silver halide formed can reasonably obtain by measuring the height of the precipitate in the reaction tube, this is not very reliable. He says that height of the height of the precipitate can be misleading. So if the height is not very reliable, we can filter the precipitate using a funnel and filter paper. We remove the liquid and take out the precipitate. We should try it and then weigh it.
Yes.
What we can do, filter out the precipitate. The use of halogenoalkanes is hazardous, and both gloves and eye protection are necessary. State one other essential precaution which should be taken when carrying out the experiment. He has covered the hands, he has covered the eyes, and these are the hazard lines. Skin and particularly eye contact, where inhaled or ingested. Okay. So should we recommend for face mask also?
Yes.
Secondly, there should not be any flammable. Question number 2. At 25-degree, dinitrogen tetraoxide forms an equilibrium mixture with nitrogen dioxide. N2O4 is colorless and NO2 is brown. The composition of an equilibrium mixture can be determined by its color. Write an expression for the equilibrium constant. Equilibrium constant is concentration of product upon concentration of reactant. Right?
Yeah. So it will be NO2 squared over concentration of N2O4.
Right.
Copied.
Then examiner says in an experiment quantities of N2O4 are left to reach an equilibrium which contains N2O4 and NO2. These are analyzed to determine the concentration of N2O4 and NO2 that are present. The results are listed in the first two columns of the table below. Complete the third column of the table to give the value of this. For each of the results of the experiment, values should be given to 360. So how should we find this value? Are we dividing it or squaring it?
I think squaring. Yeah.
Yes, we have to square it. So we are squaring it. So copy down these values. This will save the time. Only one calculation would be fine. So copy down these values. We can save our time and we can go for the graph. I'm just coming. Complete the table. We have to move to graph.
Okay.
Have you copied? Have you copied the table?
Yes.
Okay, then we can start making the graph. We want to draw, we want to get a line of best fit.
Yes. I've plotted the graph.
Have you drawn it?
Yeah.
So I'm having this green line as the graph. You can compare it.
It looks about the same, but there's some points going off the line.
Definitely, because it's the line of best fit now.
Yeah.
So when it is a line of best fit, definitely the value can change.
Mm.
Choose two suitable set of values from your graph and use them to calculate a value for the equilibrium constant. Give your answer to three significant figures. We already have told examiner in the start of the question that Kc is equal to N2, NO2, N2O square, NO2 square upon N2O4. So this means that the gradient would be used. You will have to find the gradient, and the gradient will be representing Kc. So you have to take any 2 points, but ideally do not take those points which are already in the table. Do not
Mm.
take the points which are in the table, because that will not be very impressive. So you will tell examiner that gradient will be equal to Kc. You have to take 2 points and put them in the formula, mass formula, and find the gradient.
Okay. I'm getting 5.63 times 10 to the power of minus 3.
The range is 5 to 6, 10 power minus 3.
Yeah.
Okay. Identify the result which is most anomalous and suggest a reason other than a calculation error why this may have occurred. No, sorry. Which is most anomalous. We have to look for a most anomalous point. In my case, it is this point, this one, 0.3 x.
Yes, for me too.
What may be the reason for this? The value is going much away from the line, and it means N2O4. Actually, N2O4 is registered 0.3. So N2O4, NO2 is less. Otherwise, the point will go up and it will be meeting the green line. So it means N2O4 is less. So if we go for the equation here, NO2 is our product. NO2 is our product. How we describe or how we understand this anomalous issue, this comes every year. Remember that in mathematics, if a point is on a wrong position, you have to see in the paper that how we can fix it. For example, if I move this point to the left, it will reach the line. This is option 1. Or if I move the point up, it will reach the position of the green line. So now you can see here 1 and 2. These are the two positions. So if there are these two options are there, so maybe it happened that NO2 is not fully formed. More NO2 could form and the point will rise. I'm talking about option 2. Second option is there, maybe temperature is not good enough and the reaction could have gone a bit on the back side. I'm talking about option 1. If
Yes.
if N2O4 is less than 0.3, at this point, the point will reach the green line. So whenever you have to answer anomalous point, think of two situations. Either the point will be vertically moving to get the correction, or the point be moving horizontally and the point be moving horizontally for correction. So there are two possible waves. So we have to consider only one of them. So I'm taking, for example, vertical translation. Look at this now that so maybe the equilibrium is not established fully. He says now on your graph, draw a line that would be obtained if the temperature of the equilibrium mixture was raised. Now this is an endothermic reaction. Now this is an endothermic reaction, this one. If this is an endothermic reaction, if I increase the temperature, equilibrium will move to the right.
Yes.
And if equilibrium move to the right, Kc will be greater than this value. Kc is the gradient of the graph. So if Kc increases, gradient increases. Physics says when gradient increases, the graph become steeper. So what is the theory? The theory says that when you increase the temperature, equilibrium will shift to the right because it is an endothermic reaction. More product will be formed, Kc will increase. When Kc will increase, gradient will increase. When gradient increases, the graph would be steeper.
Okay.
This is the red line. You have to copy this.
I've copied.
So you have to give an explanation for that. Endo reaction, temperature increases, equilibrium shift to the right, NO2 increases, gradient increases, graph is steeper. So you have to copy this.
Okay. I've copied.
What effect, if any, would the higher temperature have on the value of Kc? Kc will increase because equilibrium will shift to the
Right.
Kc will increase because equilibrium will shift to the right. How? Acha, first you have to copy part 3.
I've copied.
How would your value for the equilibrium constant change if the pressure applied to the equilibrium mixture was increased? The reaction involves gases. When a reaction involves gases, it is possible. When a reaction involves gases, what happens that equilibrium follows a rule of number of moles.
Yes.
Do you remember that?
Yes, yes.
So how we translate that?
So the pressure is increasing, so it will move to the side with the fewer number of moles.
Pure number of moles. How would your value for the equilibrium constant change? So pressure will increase, equilibrium shift to the left, N2O4 increases. Why I have written Kc no change?
Is it because Kc is only affected by temperature?
Actually, do you remember there was a Kp also?
Yes.
So Kp will change, Kc will not change.
Okay.
Now let's this ratio part. In the experiments, the results have been obtained by starting with pure N2O4 and then letting the equilibrium with NO2 form. Calculate the starting concentration of pure N2O4 that would be required to produce the mixture of 0.9 mole per dm cube N2O4 and 0.0729 mole per dm cube of NO2 once equilibrium had been established. So we do this, our AS calculation. We suppose initial is X and NO2 is 0. At equilibrium, A moles shift to the right, so other side will become 2A. So we put the values as he has given us and we solve to find X.
Okay.
You have to share this calculation.
Okay. I've copied.
So this paper is completed and the final answer is 0.9365. So we'll stop here and we will inshallah continue in our next class.
Inshallah. Thank you.
Bye.